Good morning, everyone, and thanks for coming back. I'm Dan, and Mary's on the camera. This is part 3 of our series on power meters, and this is doing a full installation on our DROK power meters that are out in the garage. For those of you who saw part 1 and 2 of our video series, you saw the meter that's out in the garage set up into this 3-gang terminal box. This is an old work box up through here. Then we went ahead and pulled an 18/8 wire, and that's what's hooked to this 8-pin terminal block here. We use 7 of the 8 wires. We don't use the green wire in this setup. Over the weekend, we pulled in another 18/5 wire. And out of that, we do not use the green wire. We set up another 4-pin terminal block for additional CTs. And I'm going to explain that in a moment. For part 2 of the video, you saw that in part 1 and 2, you saw that the red and black are the power wires that bring voltage into the meters. The white wire, number 3, is neutral. Number 4 is green, that's not used. Again, you can see this on the wiring diagram on our website. You just go up under our blog page and you look at the part 2 video. You can also look at the part 3 video here, but we do have it on our blog page. It's nice and clear. You can print it out, ponder it. It's great. Moving on, we've got two sets of wires. They bring in the FPL current transformer signal, and they run down into, originally they ran down directly into the meters, so that these power meters gave us voltage no matter what we had, generator or FPL. Now FPL again is our power provider, Florida Power and Light here in Southwest Florida. Over the weekend, what we did was we utilized the 2 double pole, double throw toggle switches that you saw earlier on this meter, along with the 2 half-amp fuse holders. And now we've got full functionality and turned this meter set into double duty, because now, in addition to the set of CT wires coming in from FPL for the left and right legs, we have a left and right leg CT setup coming in from the generator. So all we have to do is, if we're going to be running our generator, we can flip our toggle switches over to the left, and that'll give us our amperage signals coming in from our CTs on our generator wires while still picking up voltage. If we have the toggle switches over to the right like they are now, then we'll bring in CT energy from the FPL side, our legs coming into the house, and also the voltage there. I'm going to pause the video. We're going to put this on the table, and you'll be able to see it much clearer when we discuss the wiring diagram. All right, here's the faceplate pulled out from the wall. Again, you can see the 2 meters, left and right. You can see the labeling we put on. You can see that circuit breaker 8, circuit breaker 6 are the breakers that power the respective meters. We have 2 inline fuse holders that hold half-amp fuses. We also have a double pole, double throw toggle switch here and here, which means we can, as we're currently set, we can monitor current from FPL. When we flip the switches through center and over to the left, we can monitor generator, and that's done like this, just flipping back like this. That's it. So we'll go back to FPL for now. Now what I'm going to do is turn this thing over, and you can see the mess of wiring, and by the time we're done with the explanation, you'll really understand what's going on. So if we just give it a quick flip, you can see the new 4 terminal block we put on. We got the 8 terminal block here. Just a quick discussion. With the wiring that comes in, the voltage comes through here on the left side. I'm going to move this just a little bit. The voltage comes through here on the left side. You can see that on each meter. The current goes into the green terminal blocks here. Now when I say current, I'm talking about the CTs, the current transformers. The signal initially came from FPL and just went right into here, but we now have these meters doing double duty, because now we can do FPL or generator amperage coming into here. Regardless of how this is set up, because of the fact that breakers 6 and 8 power this meter, and that's above the generator breaker and above the FPL main breaker in our house, we get voltage no matter what. So whether it's on generator or on FPL, we get voltage readings. The switch happens when we switch from FPL current to generator current. Now I'm going to take this meter assembly and turn it around. We're in effect setting up so that our meter assembly is upside down, but that just makes it easier to see the wires that are here, which you can see right here. So to explain this, it looks like it's just a bunch of junk, but it's actually really simple. We have a switch and a switch, and now because we've reversed this thing around, this is the left switch for the left meter, which is on the right side. This is the right switch for the right meter, which happens to be on the left side here. So once you look at the wiring diagram, you'll understand it. But quite simply, we know that with this little 4-banger here, those are 2 extra CTs that are coming in from the generator wiring. Those come in on the left side of these switches. The red and black wire on the right here, and the red and black wire on the right here of the toggle switches, those are the CTs that come from FPL. The wires in the middle, they come out of the switch and they go to their respective meters, a CT hookup, the CT terminal block. So this is the left switch going to the left meter. This is the right switch going to the right meter. Again, keep in mind that we are upside down here, okay? Now this works because normally when you have a toggle switch, you send energy down through inside the middle of a toggle switch, and then you send it off by virtue of however you switch the switch, you send it off to whatever component. But the current flow is reversed in our scenario because what we want to do is bring in 2 different current transformer energy packets here, and then we wanted to make a choice in the switch of which one gets sent to the meters. Hence, if we have FPL current coming in here and we flip the toggle, it'll come into the switch, come through these wires and get read by the meter. If we have the generator running, the generator will be bringing in its current signal here. It'll go through the switch and go to the meter. So that's the whole idea behind that. Now I'm going to pause the video and just set up the wiring diagram, and that should make it even easier. Keep in mind this wiring diagram is on our website under the blog section. That'll make it very easy for you to look at it, print it, download it, and ponder this should you try a complex meter project like this. All right, here is the diagram, and this is a graphical representation of this mess here. So I'll just leave this back here. You recognize our 8-pin terminal block and our 4-pin terminal block. You remember for the 8-pin that we've got a black and red wire coming in and a neutral. Those 3 send power to the meters. Now the meters are not listed here. This is the current transformer setting on the left meter and the right meter. This is the right switch and the left switch. And again, we're reversed because that's the easiest way to understand this. The green wire is not used. And then we have a blue and brown wire coming in. And those are CT wires from FPL, and they go on to the right side of the left switch. Then we have an yellow and orange wire, and they go to the right side of the right switch to go into the right meter. Now what we do is we come over to the 4-pin terminal block. We have a black and red wire that come down through, and they go over to the left switch on the left side. And then the blue and white wires come right down to the left side of the right switch. In the middle is where we send the signals into the CT terminal, the terminal block on the power meters. And that's it. So when we make our switch from left to right with the toggle switch, that tells us which signal, which side, whether it be FPL current or generator current, we're going to send over to the meter. So hopefully that makes sense. If not, stop it, rewind it, print it out, draw your own representation, whatever it takes for you to understand how this works. We're going to pause the video now and we're going to go over to the circuit panel. But you know what? Instead of doing that, let's do a little bonus. We're going to pause this and show you how we actually cut these things out. I'm not actually going to cut an opening in the faceplate, but I'm going to show that to you now since you stuck here and watched the video for so long. So hang tight. All right, we're back. So this is what we generally do with a faceplate. This is a 2-gang switch plate, as you can tell at this point. Now normally a switch plate would go on like this. You would have holes in the bottom, holes in the top, you'd have your light switches, etc. This is a blank plate. Because we need room for the meters, we turn it to the side. Then what we do is we take measurements off of our power meter and get an idea of what the width is and what the length is. You also have to factor in, and see if you can see this, there's a flange on here that comes around this particular meter. You need to cut the hole a little smaller than the meter. So now what we do is we actually draw pencil lines, and you can use blue tape or whatever, masking tape. We don't. We just free draw pencil lines because pencil just rubs right off when you're done. So we make out our rectangles, and then what we'll do is we'll take a drill and we'll take a small drill bit and we'll drill through each corner and mark this. Then what we do is turn this thing around and we'll get a Dremel with a cutoff wheel, and then with that Dremel we'll also use a high-speed cutting bit. And what we'll do is we'll just gently take our time and start cutting a level line. And if you want to mark the pencil lines on the back side as well, you certainly can. We've had no problem just marking them on the other side. Once we get our 4 holes, we can line everything up. But you gently cut everything out and you cut 2 rectangles. When you're done cutting the rectangles, you'll file them, you clean them, you make them nice. Then what you do is you fit your meter. And you'll have to play a little bit in order to get the meter to fit so that you get to the final step, which is grinding out just a little bit of a tab on each side of the rectangles, because when you look at the power meter, if you can see this, the power meter has a little meter clip right here. You see how it sticks out a little bit right there? That's what allows this to lock into the plate. So once you get all your drilling done, you can take your meter and lock it into the plate. And man, that looks like $100 right there. The flange, it looks great all the way around. It doesn't have to be super perfect on the back side, but you want it enough to hold the meter securely. But that's how you do that, and that's the bonus we wanted to share with you. Now we're going to pause the video and go into the circuit box and then just finish up showing you the wiring for this extra set of CTs, and then we'll show the finished installation up on the wall. All right, this is giving you a macro view of our, hello everybody, I'm Dan. This gives a macro view of our circuit panel. When you look underneath here, you'll remember that in part 1 we talked about this 18-8 wire group coming down through, running down through, and the green line is not used at this time. Then in part 2 we talked about the second group of wires, actually in part 1 and part 2, and look at even in part 3. We talk about the second group of wires that comes down, and this group of 8 wires runs down through, and this is for the DROK power meter that we're actually putting together here today in the garage and finishing up. Finally, this weekend we ran a third wire. You see the gray wire here, that's an 18-5 wire. We happen to have about 54 feet of wire laying around, so we decided to use that wire to run it down through to hook up an additional set of current transformers, and that's how we got double duty out of our power meter. I'm going to pause the video, I'm going to bring the camera closer, and then break down what we have for CTs. All right, we're back inside the circuit panel for a closer view. I'll start at the bottom here. You'll notice that these CTs, there's one here and there's another hidden behind these wire nuts. These are the current transformers for the Murata power meters. Those are located inside the house, and we discussed the installation of those in part 1 of the video. You also notice the 2 current transformers that are located on the incoming wires coming into our house from FPL. They were located down here. We decided to move them up and then just put a little zip tie to keep them in place, because now we can put a digital clamp meter on these things and do readings. And we also have room for a second set of transformers, current transformers, for another meter project, which you'll see down the line. That's going to be pretty neat with a different set of meters. Anyway, these CTs are the same as what you see up here. So these are DROK CTs here. Let's turn the screwdriver around so we don't get shocked. And these generate the energy from the induction from the power coming into the house from FPL. When we have the main breaker shut off and the generator breaker is on, then the power comes through the generator wiring from outside. And these are the same DROK CTs over here that are here. These will pick up the generator wire and send the signal back to the meter. These hook to the 18-5 wire, which go back to the panel, back to the faceplate and the meter on the other side of the garage. And that's how we are able to grab the current readings from either FPL or from the generator. Now, just as an aside, you may recall breakers 6 and 8 in our part 1 video. That's where the power is coming from for the meter. So we get voltage above the generator and above the main breaker, no matter what we run, whether we're on generator or FPL. So that doesn't change. What does change is our selection of current. So now we're going to pause the video. I'm going to bring it back around to the other side of the garage and show you the full installation. All right, we're back at the completed meter. It's all screwed into the wall. The meter assembly is set to go. Again, you'll notice our power, 124 volts on each side. Now we're running 10 amps and 7 amps. Our AC is pulling some amperages at this time. Again, you see the fuse panels. You'll notice the toggle switches are switched. Now, if we were to run over to generator power, we would simply shut off the switches, bleed out the current, and then flip over. And now we would be on generator and generator. So that's how we make this power meter setup do double duty. I'm going to go back to FPL. And again, you see the generator, or excuse me, the meters loading up the amperage from FPL, 10 amps and 7 amps. Now we have 124, 123. So you always get a little fluctuation in your stuff. And that's it. This is a very neat, clean, professional setup. I'm going to back off the camera, and you can see where it's located right over here on the side of our garage. So it's right next to the door. We can come in and out. Real easy to just check on the meters and see how we're doing. Now, a couple things here, a couple bonus things to think about. You might hear people say, you can't do this. You can't set up this kind of thing with power meters. Well, actually, yes, you can, because one of the rules about current transformers is, you know what, I'll get a current transformer and share this information with you. If you have a current transformer, which is here, and I just need to double check that I'm in the camera, you have a current transformer and a wire is running through the current transformer. As energy goes through that, the primary and secondary windings of the CT start to pick up power and send it down the wires. Technically, you should shunt these off so you don't have a power issue being generated in the wires. Now, we talked about being set up on FPL and generator. We're set up on FPL right now. If we're going to flip over to the generator, we're not going to have any power coming in from FPL. We will have turned off the main breaker, so these would read 0. So there's not going to be any induction-induced energy coming through the transformer. We flip over to the generator fires up, the power starts going through the generator wires, generating through the primary and secondary windings on the CT, sending a signal into the meter, and we get generator current readings. So that's the magic of this. Once you realize that you can do more than one CT setup on a situation like this, you're not generating a lot of power off the signal. And as long as you set it up safely, you have the wires protected inside, as you see, you've got insulation around, shrink wrap, etc., and you do this work properly, you can take one set of DROK power meters or any other power meters and have them do double duty with the addition of 2 double pole, double throw toggle switches. It really works well. We hope you like this video. We understand it's a long video, but it's designed for those people who are willing to stick it out and really learn the details in order to put together a very professional, safe, neat, and clean digital meter setup in their home. Please like our video and subscribe it, but only if you like this sort of thing. Please feel free to share it with others who might like this sort of thing. We've got other videos coming down the pike. Thank you very much for your support. Please drop any comments down below, any suggestions for us that we can use to make our projects better. And if you have any questions or comments about how it may have helped you, we'd love to hear them. Thanks, and we'll see you on the next video.